Hi everyone, I hope you've all been well and had a productive August and September. Today I'm going to be talking about using YubiKeys on NixOS to achieve passwordless touch authentication for both sudo and SSH. There's also some bonus information at the end for using them for LUKS2 decryption as well as Git signing. And of course, the steps described here can also be used on other Linux distros, but who cares about them anyway? There's a lot of different uses for YubiKeys that we won't be covering today, but these ones are well worth exploring. If you're like me, any repetitive annoyances throughout the day can lead to a lot of increased frustration over time, so any quality of life improvement, however small, that makes my workflow more comfortable, convenient, and efficient is very welcome. One of the most common daily irritants for everyone is authentication, especially now that multi-factor auth of some sort is a necessity. With a solid password manager like ProtonPass, authentication on the web or mobile is less of a bother than it might be otherwise, but this doesn't do much to help our time spent in the command line. I happen to fat finger my typing far more than I care to admit, so whenever I sudo something or SSH into a commonly accessed box and need to provide the requisite passphrase, I'm likely to fuck it up and have to try again, all the more frustrating when I'm in a hurry. Sure, I could take the time to copy the passphrase from my password vault and paste it into the CLI, but there's a much better solution using YubiKeys. If you're not familiar with YubiKeys, they are a USB device that has NFC and touch or biometric sensors on them. The sensors are physically pressed or NFC tapped to verify the user's presence and provide data used in various types of authentication. There are several different models ranging from a low-profile nano to a larger format biometric pad that is still very small considering its capability. I've been using the YubiKey 5 Nano, which was about 60 US, and the YubiKey 5 NFC, which was about 50 USD. I've been using them for at least 5 years, and they've paid for themselves multiple times over in convenience. A couple of assumptions here. I'm not going to go through the basics of setting up a YubiKey. I'll assume that you already have one and sort of know how to use it. Also, we'll be following the structure of my nix-config and making use of the SOPs-based nix-secrets. You don't have to follow the specific structure or have your secrets in a private repo like I do, but it's worth knowing the structure because I'll be referencing it. Yubico, the company that makes YubiKeys, provides an excellent authenticator management and access tool in GUI form called YubiOS on NixOS and a command line form called YubiKey Manager. Among other things, we can use these tools to view device information, store and access one-time password accounts, and configure device settings. I personally keep YubiOS open in one of my workspaces for accessing OTPs throughout the day. YubiKey Manager can be accessed directly on the CLI via the ykman command, and we'll be making use of this in a couple of the scripts that we'll go over to manage multiple YubiKeys. To start with, we'll create a YubiKey module in our host's common optional area, and this is where we'll declare the bulk of the YubiKey configuration. So this module will install both YubiOS and YubiKey Manager, as well as PAM U2F, which we'll need for PAM authentication when we're using our YubiKeys. Below those packages, we'll also enable several service-based packages. PCS-CD enables YubiKey Smart Card Mode, CCID, which is used for USB detection. The YubiKey Personalization is a CLI configuration tool that provides options beyond what are available in the Authenticator tool. We'll be using it to quickly reference our YubiKeys serial codes later on. YubiKey Agent is an SSH agent specifically for YubiKeys. The package will automatically create and start a systemd service unit for us, and for this to be effective, we'll need to ensure that our SSH keys are passed through to the agent. So we'll do this later on in our SSH module in a later step. So with the packages set, we'll declare the PAM options we'll need, including SSH agent auth, U2F, which is universal second factor, and their related service options. Make note of the path we're setting for this auth file for U2F. This doesn't actually exist yet, but later on we'll be generating U2F keys and they'll be pointed there with a symlink. Next, we'll need to import the module into whatever hosts we want to use it on. So for this example, I'm going to use Ghost, which is my primary desktop, finally running NixOS on a daily basis, which is fucking awesome. At this point, we can do a NixOS rebuild to have the packages installed and start the services. You'll also want to make sure that you git add the YubiKey module prior to rebuilding, or Nix won't know that the file exists. So for those using the just file from my nix-config, we can run just rebuild. Now we'll set up a FIDO pin for your YubiKey. If you haven't already, it's a good idea to set up a memorable FIDO pin. This pin will be required when managing FIDO-related tasks with your key, such as YubiKey-based key pair generation via SSH keygen, and when you're using YubiKey for LUKS2 decryption. Keep in mind that you can set different pins and settings for each of the protocols supported by your YubiKey, FIDO, OS, OpenPGP, but we're only focusing on FIDO here. So to set your pin, Run ykman FIDO access pin change and follow the prompts. If you have multiple keys, you'll need to run the above command on each of them. And to avoid complications, I only ever have a single YubiKey inserted in my box at any time. Are we still doing phrasing? Next, we'll generate and store YubiKey-based SSH key pairs. Now that we can actually use the YubiKeys on the host, the first thing we'll need to do is generate private and public key pairs for each of our YubiKeys. I name each of my YubiKeys with a 4-letter word beginning with the letter M and prepend the SSH key names with ID underscore. So for example, 2 of my keys are Maya and Mara, and their associated public and private SSH keys are ID underscore Maya, ID underscore Maya.pub, and likewise for Mara. The naming will come in handy when we're saving and retrieving our keys from the nix-config and nix-secrets. So to start setting up the keys, we'll run SSH keygen using the following flags. We'll append SK to the encryption type that we set, which will inform the SSH key that we want to use a security key device, and it will prompt us accordingly. We use -n with an empty string so that we don't need to add an additional SSH passphrase. Confirmation of the YubiKey presence and occasionally providing the FIDO pin will suffice. Of course, for the comment, you want to add your own user and the device name as mentioned, and we'll set the file to save in the typical home location of .sh. When you're prompted to enter the pin for authentication, enter your FIDO pin that we set earlier and press enter, and then you'll be prompted with the following message and your key will blink. Touch it to confirm your presence. Then you can list the contents of your .sh to confirm that both the public and private keys were created. Repeat the steps for each of the YubiKeys you have, changing the device name to suit your preferences. Now we want to store those public keys in our nix-config. To conveniently share the public keys across our hosts, we move them to hosts common users, username, keys. We'll need to reference the public keys from their expected location in .sh for normal operation. So we'll make that happen with a modification to our home common core SSH file. We add a let block that contains 3 bindings. Path to keys defines the path to where we'll be storing the public keys in the nix-config. YubiKeys returns a list of all the public keys we're storing in the path to keys, and then YubiKey public key entries returns a set that maps each public key in that path to keys binding to a symlinked file in our .sh. We'll put the rest of the module behind the in block and append the end of the programs.sh set with our YubiKey public keys entries binding so that when the module builds, the symlinks are created. While we're here, we also want to make sure that our keys get passed to the SSH agent, as mentioned earlier when we enabled the YubiKey-agent service in our YubiKey module. To do this, we set add keys to agent yes in the ssh.extraconfig option. We access many of the hosts in our nix-config remotely over SSH, so it'll be convenient for the keys to automatically be authorized in our etc SSH authorized keys. To achieve this, we'll make a couple of additions to our common users module under hosts. In the let block, we'll bind pub keys to a list of all the keys we have in our hosts common users username keys directory. Then we'll use the following option to write a file to our etc SSH authorized D that contains the values of each pub keys item. In my case, my primary user and root are effectively the same, so I add the same option for my users.users.root declaration. With our public keys set up, we'll move on to our private keys. We'll add our private key data to the secrets.yaml file of our private nix-secrets repo using sops. As you can see in this structural example, I save mine along with my other private SSH keys. Take note of the hierarchy you use as we'll reference it in the next section. With our private keys added successfully to our secrets file, we'll add the keys to our home level sops nix module to make sure that they are extracted from our secrets when sops runs for the respective user. We'll add these keys to the secrets section of our .sops next. Make sure to update the device names to match your own names. Now that we have our public and private keys stored in our nix-config and nix-secrets respectively, we'll make sure that they don't exist in our .ssh before we rebuild, or they will stop Nix from writing symlinks for us. Since we already moved the public keys over, they should be taken care of. However, we can ensure that both public and private keys are deleted from our .ssh by running the following command for each of the YubiKeys we added in the previous step. You could also just move these files and append them with a .bkp as a backup until we confirm that nix-secrets will actually extract the data correctly. So with those changes complete, you should be able to rebuild and confirm that the keys are symlinked correctly. Make sure to commit and push your nix-secrets changes and update so that nix-config inputs the new data on rebuild. Using our just file, we can just rebuild update to ensure that we get the data we push to nix-secrets. After the rebuild, run ls-l on .ssh, and you should see something similar to the following. Note that both ID Mara and ID Maya files are symbolically linked to the actual Mara and Maya files that were extracted by my home-level SOPs module to my .config sops nix-secrets SSH keys. Similarly, the public keys for Mara and Maya are symbolically linked to the location in the nix store that they were saved from my nix-config when it was rebuilt. So before we actually use the keys for SSH, we'll want to make some additional quality of life improvements. If we define SSH identity files for each of our YubiKey SSH keys, then they will request authentication one at a time until success. So for example, if we have ID Maya followed by ID Mara listed as identity files, but only ID Mara is plugged in, then SSH will ask us to verify presence for ID Maya first because it doesn't know that it's not plugged in. We'll have to wait for the request timeout, after which we'll be asked to confirm presence for ID Mara. Obviously, the more keys you have defined as identity files, the more problematic this becomes. To mitigate this, we'll use some proxy key files called id_YubiKey and id_YubiKey.pub in our .ssh and use some scripts to automatically symlink those files to the respective private and public key of whichever YubiKey has most recently been plugged in. To start, we'll create two bash scripts in our host's common optional YubiKey directory that we created earlier. The first script, YubiKey up, will get executed whenever a YubiKey is plugged into the host and symlink that device's SSH keys to our proxy key files. On the line with the declare call, you'll have to replace Mara equals number and Maya equals number with the device names you gave your YubiKeys in the previous step, along with their specific serial numbers. To find a serial number for your YubiKey, you can run ykman-info while the device is plugged in. This will spit out some information that looks something like this, and you can find the serial number here. When the script is triggered, it will reference the YubiKey's serial number and match it with the device name you gave it. Then it will symlink ID_YubiKey and ID_YubiKey_pub to the actual keys for the device. If a YubiKey is plugged in that doesn't match one of the serial numbers, the script will exit with a message that prints the serial number and makes it a little easier to add it if need be. The next script, YubiKey down, is much simpler. This script simply deletes the two proxy keys when it runs. We'll now need a way to execute these scripts under the desired trigger conditions. To do so, we'll add a few lines to our YubiKey module in the nix-config. In the let block, we'll bind YubiKey up and YubiKey down to our bash scripts using packages.writeShell application. For YubiKey up, we'll also make sure that it inherits the Gawk and YubiKey manager tools that it uses. Next, we'll modify the environment system packages value using lib.flatten to take in our previously declared packages, along with our newly created shell packages that we bound to YubiKey up and YubiKey down. Lastly, we define a udev entry that will trigger the appropriate script whenever a YubiKey is plugged or unplugged. So we're nearly ready to use the YubiKey for SSH auth. In this example, we'll add the path to our ID_YubiKey proxy file to a match block for GitLab and GitHub in our SSH module. This way, whenever we SSH to either gitlab.com or github.com, our SSH client will know to use our YubiKey for authentication. You'll see that after the path to ID_YubiKey, there's another identity file defined for one of my SSH keys that is not associated with a YubiKey. This is a handy fallback when using SSH for a host when a YubiKey isn't plugged in for some reason. When that happens, or if something goes wrong with the YubiKey itself, SSH will eventually land on that key and prompt for the passphrase to be entered. If you didn't bother setting up a proxy key for YubiKeys, just add the paths to the keys that you want to use for authentication to those domains. You're prompted to authenticate for them in the order that they're listed until one is successful or the list is exhausted. You'll want to create match blocks for each of the hosts that you'll connect to using a YubiKey. And also make sure that for each YubiKey you add to the match block, regardless of whether or not you're using a proxy key, you add the actual public key for that YubiKey to the hosts in the match block. This is standard requirement regardless of YubiKeys being in the mix. If you're looking for additional examples of match blocks, you can see some in my personal ssh.nix in my public repo, but the file is much more complex than it is here. So now let's test it. With our changes complete, we can rebuild and test our results against GitHub using the following command. Our YubiKey should flash as we're prompted to confirm presence. Simply touch your YubiKey and you should see user presence confirmed, followed by a greeting and a closed connection. Enabling passwordless sudo is much less involved, especially considering we've already enabled some of the required options. To accomplish this, we'll make use of U2F keys specific to each of our YubiKeys. The following steps write U2F keys to a temporary U2F_keys file in your home. This file would typically be written to the following path that we specified earlier, but we'll be storing this key data in our nix-secrets and auto-extracting it to the typical location using sopsnix. If you're not using secrets, you can replace the temporary short path with the actual path. To generate U2F keys, we'll use the pam U2F config tool from the pam U2F package we installed in our YubiKey module. With one of your YubiKeys plugged in, run the following command, replacing username with your actual username. You'll be prompted to touch your YubiKey. After touching the key registration data for PAM will be written to the U2F keys file. For every additional YubiKey, we'll use a slightly different command. With only the next YubiKey you want to add plugged in, run this command. After touching the YubiKey, the registration data will be appended to the U2F keys file. The -n flag we used will instruct the config tool to output the registration data as an amendment to the data of the first key, thus skipping the prefix information that it would normally generate. Repeat the steps to add any additional YubiKeys you have. Now we'll add the U2F keys data to the secrets file in our private nix-secrets repo using sops. We can cat the contents of the U2F keys file we just created and copy the data to a new entry in our nix-secrets that looks something like this. Save the file, commit, and push your changes to nix-secrets. To have the U2F keys extracted from our nix-secrets when we rebuild nix-config, we'll modify our hosts level sops module. The user and group options ensure that U2F will have the correct permissions to access the data, and the path option specifies where the file is expected. Now we can just rebuild update again to get the updated nix-secrets we pushed. Once the rebuild is complete, we should see a symlink in our .config Yubico directory as follows. At this point, we can also remove the temporary U2F keys file we generated as it's no longer needed. To give passwordless sudo a try, simply sudo su in a new terminal, and the YubiKey should blink and you'll be prompted to touch it. As soon as we get used to touching YubiKey for sudo, we'll likely be annoyed whenever we can't do it. And this happens particularly when connected to a remote host. Fortunately, we can solve this on our own remote hosts with an addition to our OpenSSH service module. Ideally, we'd do something more similar to what we did in our SSH config module file and just add the following. However, SSH agent auth is unfortunately too old to support YubiKeys, so we make use of RSSH, which was designed specifically for this scenario. If you're interested in reading more, there's links in the description below. By enabling this rule, any sudo authentication requests we get while remoting to one of our own hosts over SSH will be passed through to the YubiKey on our actual host. Depending on the scenario, the YubiKey may blink at you for touch, but there otherwise won't be much indication that you should touch it, so having an on-screen notification is highly recommended. While there is a queue option that we set in the YubiKey module, it will only prompt us in the CLI, so if we're looking at a different window when the request comes in, we'll miss it. We can solve this using the following Home Manager module found on GitHub. All the credit for this module goes to Barbiche. I hope I'm not butchering your name. To set the module up, we'll add the code as a custom Home Manager module in our nix-config here. And then to make sure that the module gets picked up, we'll modify the default file in our module's home manager as follows. Then we'll enable that module on the home of each host we want to use it on. The home module for my primary user on Ghost is as follows. With this setup, your notification tool, Dunst in my case, should notify you that your YubiKey is waiting for you to confirm presence. We can also use our YubiKey SSH keys to sign our Git commits. This is only beneficial if the SSH key you sign your Git commits with has a passphrase, of course, so in that case, just don't bother. To set this up, we can modify our Git module to point to our ID YubiKey public proxy for signing. Of course, you'll also need to have the actual pub keys added as allowed signers and added to your GitHub, GitLab, etc. profile. Hard drives encrypted with LUX2 can be enrolled with YubiKeys as a decryption mechanism in addition to the manually entered passphrases. Keep in mind that the YubiKey FIDO pin we set up will be required prior to confirming presence on decryption. To set this up requires the YubiKey Manager package we installed earlier and assumes you already have LUKS2 encryption set up for your drives. To enroll, plug the YubiKey in you want to enroll and run sudo systemd crypt enroll with the following flag and then the path to the device. Follow the prompts. You'll need to enter your existing LUKS passphrase, the FIDO pin, and then confirm presence. We'll need to do this for each of the YubiKeys you want to use and for each drive you want to decrypt with YubiKey. However, for anything but the primary drive, we're better off pointing LUKS to a decryption file on that primary drive so that we only have to manually unlock the first one. If you're interested in how to do this, let me know. Lastly, since we're running Disco, we'll want to ensure that our Disco spec includes the following FIDO2-device equals auto option. Lastly, depending on your computer, touching your YubiKey can actually become a pain in the ass itself. With a laptop, it's not so bad, but with a desktop box, you may have to reach far over to the side of your desk to confirm presence, which is better than fat fingering your password, but annoying nonetheless. I opted to buy a USB extension cable and attach the female end to my Moonlander using a small piece of copper strapping. With the YubiKey Nano plugged in, I can easily see the blinking light and touch it with my left index finger, and it's low profile enough that it's not intrusive. So that's it for this video. I hope it's been inspiring or helpful, and I really want to thank you for watching. I also want to say a special thank you and shout out to Dry March on Sean, who has humbly submitted several PRs to my nix-config, not expecting me to merge them, but they've been very helpful, and I'm happy that someone's using my nix-config enough that they'll send PRs upstream. Thanks so much for your support. Watch out for the next one, and remember, the way out is through.